Hello. Okay, so this is now lab 1-6, switching circuits. So in this lab, what we're going to do is we're going to look at the board that we just metered out to make sure which devices were what. We are then going to connect them up to the 4 different types of circuits they're going to ask us to do. They're going to ask us to connect up a single pole, single throw switch, a double pole, double throw switch, or double pole, single throw switch, a 3-way circuit, and a 4-way circuit. So I've got my lab bench, I've got my switching circuit, I got a meter that I'm going to be able to meter things with, okay? And then I've also got a bunch of test jumpers, and I've got my little diagram here. I'm also going to pull out the drawings that I did in my previous video to sort of give us a bit of an understanding on how to connect this guy up. So on the next page, what they ask us to do in step 3 and 4, well, step 3 would be to create and connect the drawing up as what's in the lab here. I'm going to ask you guys to do that on your own. Please note that we're using alternating current, or AC, okay? That symbol there is our light, all right? And then that's our single pole switch. So we're gonna connect up our single pole, single throw switch to that light bulb, all right? So the diagram, if we were to look at this, see if I can find it here. It is just that guy right there, okay? So we got our source, we're going to our single pole light, or a single pole switch, to our light, and then returning back. Okay? Now, I'm going to connect this guy out. So I'm going to come out of my line 1. I'm in my variable supply. I need to choose my single pole, single throw switch. And remember that we'd metered these cross points as our common spots. Okay? So I'm going to come out of that line 1, leave that switch, head up to my light bulb, which I'm just going to randomly choose a light bulb up there, and then I need to do a return path back to neutral from that light bulb. Okay, so if we're looking at the actual wiring and what we name these, this is my hot, or my common, or my line 1, power coming into that switch. Through that switch, out of the switch, is now my switch leg. That's my switched conductor. Okay, and then we're going up to the light, and I'm just going to pivot the camera up just a little bit so you can maybe see the light too. Okay, you'll know when it comes on because it'll be a bit brighter. All right, and then we return back to our neutral. Okay, so with that, I'm going to make sure that's zeroed off. Going to grab my meter because they're going to ask us to measure the voltage across the switch here, I think. So I'm in volts AC. Ensure that the main breaker on the power bench is off, connect it up, and then step 5 is turn on the main breaker, your power, and to demonstrate the action of your circuit. So I'm going to turn it on. I'm going to turn my volume up. My switch is in the off position, so that light bulb should not be on. I turn that, and my light goes on. See that? Magic. Let's see if we can get that on camera. There we are. Turn it off. Light's off. Light goes on, light goes off. There you go. You get the understanding there. Okay. Next, what they ask us to do is to use the voltmeter and measure and record the voltage across each of the following points. So lamp terminals with the switch closed. Closed meaning that the light bulb is on. Okay, so with the switch closed, they want us to meter the voltage. Okay, and we are sitting at 110. Okay, so that's 110 on that. Lamp terminals with the switch open. So with the switch off, what do we have up here? We should have 0, which we do. Okay. Switch terminals with the switch closed. We have continuity across this, so we should have no potential difference between these 2 points. We should have 0, which we do. And then switch terminals with the switch open. Now we've got a good light bulb up there, so in actual fact we have continuity from the neutral through this light bulb and then back to one side of the switch, and then we have a line conductor to the other side of the switch. So we should see our source voltage across this switch, which we do. It says 116 here now. we know we're around 110. I'm going to stick consistently with the 110. We've got some power fluctuations going on with this lab bench here. Okay, and that's it. That's your single pole switch. I'm going to turn my power back down again. Okay, next step in here is going to wire up my next circuit, which is, pardon me, I'll get to it. We're going to utilize our double pole single throw switch. So that's this guy here, which would be the second one. So how this circuit works or looks at is we're looking at our line 1 coming out, going through that part of the switch to our 240 volt load and then returning back. Okay, so this one we got to pay a little bit more attention to because we don't want to have an instance where we have a line-to-line dead short. That would be problematic. Okay, so they ask us to connect up 2 cone heaters in this case, okay, in series with each other. So that's up top. Just going to undo some of these jumpers here. Okay, just going to grab a short jumper to put in between the cone heaters. We're just going to go in between. Ooh, that's not a very good, yeah, that's okay. In between there and there. Okay, now this is my double pole single throw and it's going crisscross. So we know we need an input coming from this side, heading to 1, and an input from another line conductor heading to the other, and then we're going to go up to that, and we need one more jumper. That's going to be too short. Grab a longer one from this side going to the other side of the switch. So if we recall the diagram I just showed you right here, so we've got our line 1 coming out going to one side of the switch. That would be this guy going to one side of that switch. Out of that same top side, he's going up to the load, which is here. Okay, jumping over to the other cone heater, and then we're going to come back to that terminal on the other side of the switch, and then we return to line 2, which we have there. So this should work fine. All right, I'm going to turn the power on and energize slowly, just to make sure nothing blows up on us. And we're good. Those cone heaters should be heating up, which they are. Okay, so they've labeled the A's and B's here on this guy. So our A's are across the top, our B's are across the bottom, I'll put. So now they want us to measure the voltage between the switch terminals A1 and B1. So that would be the output side here. We're going to measure there with the switch closed, which it's closed right now. Okay. So with that switch closed and these cone heaters warming up, we're going to measure from line to line on the output side. And we're going to see we've only got 187 volts output here. Okay, that's the maximum we're getting. And I've lost my pen again. There we go. 187. Okay, and the switch terminals A1 to B1 with the switch open. So I shut that off. With it open, I have 0 volts because we're on the other side of it. I'll go over this in the Learning Hub. Okay, switch terminals A2 to B2 with the switch closed. Now we're moving to the other side of the switch, the primary side, closest to the source. We've got 200 volts there. We're fluctuating again. And then we're going to stay on the same side. We're just going to turn that switch open. Or, sorry. With it closed or open, we should still see we got 186. Okay. All right, so we should always see line-to-line voltage on the primary side of that switch or on the beginning side, regardless of the position of the switch open or closed. Okay, I'm going to turn that off. Turn my power stat down to 0, turn my breaker off, and that was my double pole single throw switch. Gets a little bit tough remembering all the names sometimes. You have to double check and make sure. Next we're going to have some fun and we're going to do the 3-way circuit and the 4-way circuit. These are the ones that you use most common within your household. Okay, so keep in mind my first 3-way circuit that they ask us to do. Sorry, I'm just going to flip the page here. we're connecting up 2 3-way switches to a single light bulb. And if I find my drawing for that, it is this guy right here. 120 volt source, first 3-way switch, that's my common screw. 2 travelers coming to the other 3-way switch. Out of that common screw with my switch leg, heading to my light. Out of my light, back returning through neutral to my 120 volts, okay? So we do that drawing in the lab, and they're actually not going to ask us to measure any voltage in here. All we're going to do is just connect it up. So we're going to remember the drawing that we had, come out with my line conductor, find my common screw on my first 3-way, which was this bottom left corner, out with my 2 travelers, which are both up top in this case. There's 1 and there's 2. So these travelers now have to go to the other travelers on the other 3-way, which were top right and bottom left. And then we're going to go up to my light from my other common screw to this light bulb up here. And then we're going to return to neutral down here. Okay, now note that these switches, there's no on or off indication on them. So if I turn the power on and crank it up and the light automatically comes on, it just means that one of those 3-way switches had actually made connection. So turn this on, and we do have that. That's the case. It's a 50-50 shot. So I should be able to control this from both locations. So the light's on right now. I turn it off at that location. Go to the second location, turn it on. Yes, that works. Come back to the first location, turn it off, and it works. And I should just be able to keep rotating back and forth. And we magically have the first 3-way switch, or 3-way circuit working. Okay, so next what they're going to ask us to do is to connect up a 4-way circuit. Now the 4-way circuit, if you recall, was basically interrupting the 2 travelers from the 3-way and inserting that 4-way switch in between them. Okay, so that's this guy here. We've got a 3-way, a 4-way, and another 3-way. Okay, so we need to have our line conductor going to the common of the first 3-way, out with the travelers to the 4-way input, out of the 4-way output to the other 3-way, and then so on and so forth back to the light and then back to source. Okay, no metering required here either. All we're going to do is require 2 more wires for my other set of travelers. I'm just going to unplug these travelers from this guy. Okay, and now we have to look at how that 4-way switch was working. I've got it labeled so that the input was the top left, or sorry, top right, and the bottom left. And then my outputs were the bottom right and the top left. And they need to go over to this the other traveler terminals on the other 3-way. Everything else I've left intact because it stays the same. We had our hot coming to our first 3-way and then going through all of the travelers and the switch leg up here and returning back to neutral. So if I've wired it correctly, I should be able to turn this guy on, turn my volume up. I've got everything in the off position. I can now turn that switch on, that light goes on, turn that, it goes off. Turn this it goes on, he goes off. Just keep moving through the process. The best way to check these is always to pretend like you're moving through the house. So I now have a perfectly excellent working 4-way switching circuit. Okay, if we wanted to add more 4-way switches to it, we could do that at any time. In other words, if we wanted to switch a single or a bank of lights from more than 3 locations, we just keep adding more and more 4-way switches in between the 2 3-ways. Okay, and that's it. And then we'll see you in the Learning Hub, and we'll talk about the observations and conclusions with this guy. Thanks. That was lab 1-5, I think, or 1-6.